Hi everyone, got another fun lesson for you today with our second day of 11.2. This time we're talking about areas of rhombi and the area of kites. Now a couple things that we need to keep in mind about a rhombus. A rhombus is also a parallelogram. Opposite sides are parallel. And the area of a parallelogram is base times height. So if a problem gives us the base right here and gives us the perpendicular height right here, we can just multiply base times height. And we'll be doing that from time to time. But more often, we use a different formula, and it involves the diagonals. So if you know the distance of this red diagonal, and you know the distance of this blue diagonal, another way we could find the area of a rhombus is 1/2 of diagonal 1 multiplied by diagonal 2. So the D1 stands for one diagonal, that distance. And then D2 stands for the length of the other diagonal, that distance. We can multiply those two together and take half of it. So we have these two formulas. To be honest with you, we more oftentimes use this one, okay? But both will work. All right, for our first one, calculate the area and perimeter of a rhombus with a diagonal lengths of 6 feet and 8 feet. One thing I was going to do here really fast before I move on, what we should keep in mind about a rhombus is that all four sides are congruent, and that the diagonals are perpendicular, so they are 90 degrees. Another thing about the diagonals is that they bisect each other. So this blue segment, if you cut it in half, the red diagonal is a bisector, it cuts it in half. The same is true of the blue diagonal to the red diagonal, it also cuts it in half. Okay, so those are a few things that we need to keep in mind about a rhombus. All right, now it says calculate the area and the perimeter of this rhombus with diagonal lengths of 6 feet and 8 feet. So I'll just write in here, this is 6, and this blue diagonal is 8. So what I just said, the diagonals bisect each other. So I'm just going to write 4, 4, because that would make 8. And then, of course, 3 and 3, because that would make 6. All right, let's find the area first, because that's easy. The area equals half of diagonal 1 times diagonal 2. Well, we know diagonal 1 is 6. We know diagonal 2 is 8. So the area equals 1/2 times 6 times 8. 6 times 8 is 48. Half of 48 is 24. So we have 24 square feet. 24 feet squared fit inside that rhombus. Now the perimeter is the distance around a polygon, right? So I would need to find this distance, and then all four of these sides are congruent. So if I find one of those sides, I find all of those sides or segments. So again, what angle is right here? 90, right? The diagonals are perpendicular. So now I can do the Pythagorean theorem on this green triangle. X is my hypotenuse. The side that I want to find would be x squared, would be to the right side of the equation. 3 squared and 4 squared would be my legs of my right triangle. So let's find that 9 plus 16 equals x squared. 25 equals x squared. So my side of my rhombus is the square root of 25, which is 5. So what's my perimeter? 5, 10, 15, 20. My perimeter is 4 times 5. 4 sides times 5 feet each would be 20 feet. So there is that rhombus. Let's take a look at this rhombus. This time it says calculate the area of a rhombus with side lengths of 15. So this time we know all of the sides are 15. And one of the diagonals is 24. So you could put it right here, you could put it right here, it doesn't really matter. I'll just put it right here. This distance is 24, okay? So once again, the formula is 1/2 diagonal 1 times diagonal 2. So I'm just going to put both diagonals in there, and if the green diagonal is 24, then it's got to be 12 and 12, because the diagonals bisect each other. And this angle is 90 degrees. So the area equals 1/2 diagonal 1, which is 24, times diagonal 2. Class, I don't know what diagonal 2 is. Let's find it, shall we? All right, let's call this x right here, because this is part of my diagonal. I could now do the Pythagorean theorem with this right triangle, couldn't I? 15 squared, the hypotenuse is 15, opposite the 90. So 15 squared, that equals x squared, which is one leg, and 12 is my other leg, so 12 squared. So x squared plus 144 equals 225. Subtract 144, and x squared equals 81. Square root 81, and x equals 9. So this leg, or half of the diagonal, is 9. That means this part of the diagonal is also 9 because the diagonals bisect each other. So diagonal 2 is 9 plus 9, or 18. 1/2 diagonal 1, which is 24, diagonal 2, which is 18. Woo! Let's multiply these three together. 1/2 times 24 times 18, and we get 216. What units are we talking about? Centimeters squared. There's 216 square centimeters that fit inside this rhombus. What a day. All right. Let's move on to the kite, shall we? The formula for the area of a kite, kind of nice. It's the same as the rhombus in that it is 1/2 diagonal 1 multiplied by diagonal 2. A couple things that we should keep in mind about a kite as well. The diagonals of a kite are also perpendicular, so that's 90 degrees. So we get some more Pythagorean theorem that might come into play. Another thing about the diagonals of a kite, the longer diagonal is a bisector. So that it bisects the shorter diagonal. So these red segments are congruent to each other. But the shorter diagonal is not a bisector. Like this blue length right here is not the same thing as this blue length right here. Okay, they are different. And then a third thing that we should keep in mind is that the two shorter segments are congruent. And the definition of a kite is that there's two pairs of adjacent congruent sides. So these two are congruent, and these two are congruent. So a kite is not a parallelogram. Opposite sides are not parallel. The adjacent sides are the ones that are congruent. Okay, and here's our formula. 1/2 diagonal 1 times diagonal 2. So calculate the area of the kite if the shorter diagonal is 21. So this distance right here is 21 feet. And then the longer diagonal is 48. Well, nothing too in-depth on this one. If we have the area of a kite is 1/2 diagonal 1 times diagonal 2, and we know both of the diagonals, there's really no problem solving that needs to be done. It's just multiplying 1/2 times 21 times 48. So if you take half of 21 times 48, you get 504 feet squared. And that is the area for this kite. Okay, last problem for the day. Calculate the area of this kite with BD being 16. So one diagonal is 16. AD is 10. This distance right here is 10. And DC, that segment, is 17. Okay, well, BD is the shorter diagonal. And the longer diagonal is a bisector. It bisects the shorter diagonal. So I'm just going to put 8 right here and 8 right here. Okay? So the area of a kite is 1/2 diagonal 1. We know one diagonal, segment BD, is 16 units. But how about the other diagonal? We got to find the other diagonal. So the other diagonal is this green line, this green segment, plus this blue segment. Class, what's better than doing the Pythagorean theorem once? Doing it twice. Am I right? Let's find this segment. I'll call it X, using the Pythagorean theorem. Let's find this blue segment, Y, by using the Pythagorean theorem. Let's add them up together, and that's going to be our second diagonal. Let's do this thing with this triangle right here. x squared plus 8 squared equals 10 squared. The hypotenuse opposite the 90 is 10. So x squared plus 64 equals a hundo. Subtract 64, so x squared equals 36. Square root both sides, and x equals 6. This distance from A to, I'll call it E, segment AE, is 6 units. Let's find the distance from E to C. Let's find that segment. So here's our 90-degree angle, opposite the 90, 17. You're the hypotenuse. You're going on the right side by yourself. Y squared plus 8 squared. You're going on the left side because I want to find this distance, y. All right, y squared plus 64 equals 289. Subtract 64, so y squared equals 225. Square root both sides, and y equals 15. So segment EC is 15. So class, one diagonal is 16 units long, 8 plus 8. The other segment, the other diagonal, is 6 plus 15, which is 21 units. So the area equals 1/2 times diagonal 1, 16, times diagonal 2, which is 21. 1/2 times 16 times 21 is 168. This one, it didn't give us units, so we'll just say that it's square units, or units squared. Lots of fun. There's our kite, and there is our rhombus for today's lesson. Be sure to let me know if you have any questions when you get to class tomorrow.